This video I'm going to prove Cauchy mean value theorem. This is one of a very difficult theorem in this section. So we will talk about that in a moment. We will also see some of the examples, geometrical example of this theorem. So let me just talk about that first, the statement of this theorem. The statement says that if f and g are continuous on AB, which is a closed interval, and it is also differentiable on AB, and there is one condition which says that g dash x is not equal to 0, then Cauchy's mean value theorem tells us this equation. So there is one condition in this statement where the derivative of g dash must not be equal to 0. If g dash x is equal to 0, you can see that g dash c will also be equal to 0 and the expression will become infinity. So we want to avoid this g dash. This is very surprising result from Cauchy. We know that the mean value theorem says that f dash c is equal to f of b minus f of a, b minus a, where this c belong to a and b. But here in this theorem, Cauchy's mean value theorem, we not only have one function but two functions. That is surprising. F dash c divided by g dash c, and then we have f of b minus f of a, then g of b minus g of a. We will talk about that why there are two functions. There are two reasons why there are two functions. One reason is of parametric equation. You know that what parametric equation is. Parametric equation. Parametric equation says that x is equal to f of t and y is equal to g of t. So in this case, we have these two functions over here. So by x, if we plot that while changing the value of t, we can plot any curve. So this is the parametric form, and this f and g, these are the functions, parametric functions, these appear over here. That is one of the explanation. Another explanation is as follows. Suppose f of t is the x position of particle, and g of t y position of particle. Okay, so when we differentiate f of t, this becomes f dash t, so this becomes a velocity in x direction. And also when we have g dash t, which is a derivative of g, then this is velocity in y direction, y direction. So it means that when we write this in Cauchy's mean value theorem, we have f dash t divided by g dash t, and this is velocity in x direction, and this is velocity in y direction, velocity in the y direction. So the theorem says that this will be equal to delta f divided by delta g. Delta f is the displacement ratio, displacement in x direction. So this is the displacement ratio, I would say. So on the left hand side, we have velocity, ratio of velocities, and on the right hand side, we have displacement on the interval. So on the left hand side, we have a local value. Local value look like this. This is the local value since it is not in the interval. And the global value is on the interval. So that is one of the explanation of Cauchy's mean value theorem. So this was all about the Cauchy's mean value theorem. So it will look like this. It is similar to the mean value theorem, which is ordinary mean value theorem. In ordinary mean value theorem, we have one tangent, and if we have interval, and if we just draw a line, then this is the same thing as we have mean value theorem. The secant line is equal to tangent line. But here we have two functions, ratio of two functions, and then we have ratio of displacements, or whatever the quantity is. If it is work done, then we have a different story. But remember that C is in the interval. C is in the interval. So let me just prove this theorem for you. The first thing we want to show over here is g dash x is not equal to 0, and we want to see the consequence of g dash x is not equal to 0. Suppose, so we are going to prove this theorem. The first thing we want to show is g of A is not equal to g of B. Why we want to show this? These two values are not equal. The reason is, if these are equal, the right hand side will also be 0, so we get infinity. Constant divided by 0 will give us infinity. So we have to show that g of A is not equal to g of B. Now let us take an assumption. Assume that rather than these are not equal, let me just assume these are equal. Suppose g of A is equal to g of B. If g of A is equal to g of B, then by mean value theorem, the ordinary mean value theorem, by mean value theorem, we have for function g dash c is equal to g of B minus g of A divided by B minus A. This is the mean value theorem. that we already discussed in our previous video. If g of A is equal to g of B, it means that these both quantities are equal, so we get the answer 0. So we get finally equal to 0. So if g of A and g of B are equal, then g dash C is equal to 0. But in the theorem, we have that g dash x cannot be equal to 0. If this is not equal to 0, then it means that g of A cannot be equal to g of B, since B and A are different points. So this is one of the things that we have to prove for Cauchy's mean value theorem, which we already did over here. Now the next thing that we want to show is to prove this equation. How can we prove this equation? We can prove this equation by assuming that suppose we introduce a function f of x is equal to f of x minus f of A minus f of B minus f of A divided by g of B minus g of A, g of x minus g of A. That's how we define a new function. Why we want to define this as a new function like this? That reason will be clear to you now. If we put at x is equal to A, we get this becomes f of A minus f of A will be 0 minus f of B minus f of A, g of B minus g of A, and this term in the brackets will be same, so this is also 0. So finally we get f of A is equal to 0. So we can also see that if I put x is equal to B in above equation, we also get the value equal to 0. That was the reason that we have introduced such a construction which will ensure that two values are equal, and these values are equal since these are equal to 0. Okay, these values are equal. Rolle's theorem says that if you have f of A and f of B equal and they are in this case equal to 0, the Rolle's theorem does not require that this value should be equal to 0. It just requires that the two values must be equal. And Rolle's theorem says that if these values are equal, then we have f dash c equal to 0. That is the statement of Rolle's theorem. So what we do, we differentiate this equation. So when we differentiate, we get f dash x is equal to the derivative of this function f dash x. This is just constant minus this value is also just a constant. So we have f of b minus f of a, g of b minus g of a, and g dash x. And we know that mean value theorem and the Rolle's theorem says that there should be any c. So we replace this x with c. We replace this x with c. Over here, this becomes c. then we have this C over here, then we have this C over here, and the Rolle's theorem says that this will be equal to 0. After some manipulation, we can write it as f dash C is equal to f of B minus f of A, chi of B minus chi of A, chi dash C. Dividing both sides by chi dash C, we get chi dash C, and this will be cancelled out. So this is our Cauchy's mean value theorem. This is our Cauchy's mean value theorem. Cauchy's mean value theorem. So the proof is very simple. What is the geometrical interpretation? The geometrical interpretation is, for example, if we have 2 points, one point is chi of A and f of A, and another point is chi of B, f of B, and this curve is generated by using the parametric equation. Suppose we have such curve over here. So the theorem says that if you join these 2 points, for example, these 2 points, you get a secant line, and there is also one tangent line which is parallel to this secant line. So this is tangent line, this is tangent line, which is slope, and this is the slope that we are talking about in terms of parametric form, and that is f of B minus f of A divided by chi of B minus chi of A. This is slope of this secant line, and this is slope of tangent line, and we have f dash C divided by chi dash C. This is slope of tangent line. This is the interpretation of Cauchy's mean value theorem. Okay, why we needed this Cauchy's mean value theorem? One of the restriction with with the L'Hopital rule is the L'Hopital rule is when we apply limit x approaches to A, f of x, g of x, then we apply, for example, limit, if these are equal, limit x approaches to A, f dash x, and we have g dash x. One of the limit is g dash has some issues. So we want to remove the right hand side with from the derivative with the another function, something like that, or maybe like that, the ratio of these two values. So this was all about the Cauchy's mean value theorem. Thank you for watching.